Howdy guys, Jimmy Song here. I wanted to talk in this video about the inflation bug that was in Bitcoin. This was, a bug that was revealed by Core a few days ago, and basically they said it was a denial of service vector. And then a few days later, they released a full press release or full thing on the website saying that it could have caused inflation in a particular instance. Now, I have an article coming out a little bit later that I'm still working on at the moment, but I wanted to get this video out just to calm people down a little bit. There's a lot of people just sort of going hysterical about what happened. They're like sort of exaggerating the extent of the bug and so on. So I wanted to get some facts out there. First of all, you have to understand what the bug was. The bug was with respect to a double spend. You guys might have heard of what a double spend is. It's when Alice tries to spend to Bob and to Charlie with the same coins, right? Like same $10 bill being spent two different times. And you can't do that, right? Like at least with a physical dollar bill, you have to give it to one or the other. Yeah, it's sort of restricted that way. Digitally speaking, one of those transactions gets into a block or the other, and that's how it gets resolved. There's a more subtle way of double spending that this bug was about, and that is with respect to the same input being spent twice in the same transaction. So it's kind of like Alice giving Bob one $10 bill and pretending that it was 2 or 3 or 10 or something like that, and Bob receiving it and thinking he has 20 or 30 or $100, like because that's what Alice gave him. But of course, Alice only has $10, so that would be inflating money. That's essentially inflating by however much it is. Now that is bad. Okay, there's no two ways about it. That is really bad. That's an inflation bug. But let me just go over exactly the conditions under which this bug would have executed. So you could construct this transaction and you could have broadcast it on the network. And say you're not a miner, you don't have the cooperation of the miner, you're just hoping, okay, well, I found this exploit. I'm going to create this transaction and see what happens. Well, if you created that transaction and you sent it to whoever, they would all reject it. That's because, at least in the mempool code, for Bitcoin Core, that particular check is made. Goes, oh, okay, well, this transaction has the same input twice. It's an attempt at a double spend. It's an invalid transaction. I'm going to reject it, and that's something that every core node does. The only way for this transaction to get into the ledger is having a miner do it. By including it in a block without it ever showing up in another mempool. So you have to have either the cooperation of the miner or you need to be a miner yourself. And you need to mine that block. Now, as we know, mining a block is kind of expensive. It requires proof of work, and proof of work requires a lot of energy and computing power and so on. And once you have that, it goes into the block, right? Like, and it costs you however much in electricity. At the very least, from an opportunity cost standpoint, that's like 12.5 Bitcoins of opportunity that you're going to have to commit in order to execute this attack. Anyway, if a miner were to do that, then this is what would have happened. So before 0.13, any nodes pre-0.14 or any Bcoin nodes or BTCD nodes or libBitcoin nodes or other implementations of Bitcoin, they would have all rejected it. They would have said, okay, well, this is not a valid block because this transaction is not a valid transaction. Done. If you are a Bitcoin Core 0.14.x node, then you would crash. So that was the denial of service vulnerability. If you are a 0.15.x or 0.16.0 or .1.2, then it would have been an inflation bug. You would have just sort of accepted that block and not check for that transaction, in which case you would have inflated a little bit. But this is the interesting thing about Bitcoin. Because of all of those other nodes, which would have rejected that, you would have had some sort of conflict. You would have had a chain split. People would have known right away. As a matter of fact, a lot of Bitcoin block explorers are actually running off of alternate implementations or their own implementation. So we know, for example, that the Insight node, this is a block explorer made by BitPay, runs on top of Bcoin. So those block explorers would have known right away, and they would have rejected that block, this potential attacking block. And people would have known right away. They probably would have fixed it, figured out what it was. Maybe there's a few blocks that are mined on top of this attack block that would have been invalidated. But essentially, people would have figured this out. Like there are people that are like sort of making it out to be, well, it would have been catastrophe for Bitcoin if somebody actually attacked it. That's not true. It wouldn't have necessarily resulted in the massive inflation that they're sort of claiming. It would have maybe caused like some sort of like a block reorg or something like that. But ultimately, it would have the sanctity of the 21 million wasn't really ever in danger, because that would have been clearly a bug and not something that was intended. Now, after that, after they discovered it, they patched it right away. It took about 3 days. There was a report that it was actually a BU developer that reported it. I'll have another video on thoughts about that. But regardless, that's what the bug was, and people are sort of making it out to be this catastrophic thing. I mean, maybe it is. I mean, to some degree, there's some severity to this bug that maybe wasn't in other bugs. Like if you had some UI error in the Bitcoin Qt client or something like that, that would be one thing. This is a consensus bug, and that's a bigger deal. That said, it's extremely hard to exploit. It would have cost a lot of money, and likely the attack would have failed anyway. So from a game theory standpoint, there wasn't really much to gain other than to disrupt the Bitcoin network. And in order to do that, you need some mining equipment. And if you already have that mining equipment, you're probably already trying to make the Bitcoin network better, or trying to gain money from the Bitcoin network rather than attacking it. Now, I mean, is it possible that somebody could have shorted Bitcoin, produced this attack and made money off of it? Possibly. But at the same time, here's the thing about doing something like that. Bitcoin is pretty anti-fragile. Whenever it survives an attack, it tends to go up in value. So, it's kind of a dicey situation. So game theory wise, I don't know if there was a good way to exploit this thing. There's enough risk that I don't think anyone actually would have gone through with it without really, while benefiting it from it economically. So that's basically what I wanted to say. I'll have a bigger write-up. I'm trying to look through the code and figure out exactly what it was that caused it. I think I have most of the pieces. I've confirmed with several core devs, what the problem was. So once I have a clear idea, I will publish something. But yeah, hopefully this helps you. This song is done.